Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the attributes and key features of quadratic functions, Part 2. In today's lesson, we will be discussing the axis of symmetry of a quadratic function and how to find the axis of symmetry. So, before we start, let's start with a definition. Let's start with the definition for axis of symmetry. Parabolas representing quadratic functions are symmetric about the vertical line that passes through the vertex of the parabola. Each point on the parabola will have a point with the same y value and the same distance from the axis of symmetry. Think of these points as mirror image points. Now, let's give you an example for what those words mean. A quadratic function is shown to the right. Draw a dashed line to represent the axis of symmetry and label each point. So, in this particular problem, our vertex, or our turning point, is right here. So, our axis of symmetry is the vertical line that passes through the vertex. So, I'm going to use a dashed line because it's not really a part of our function. It's like an imaginary line here that cuts the parabola into two parts, a left side and a right side. Now, in this problem, our vertex is at the point 1, 0. Now, if I go 1 unit to the right and 1 unit to the left, let's see what our coordinate points would be. So if I go 1 unit to the right, that would be at x equals 2. If I go 1 unit to the left, that would be at x equals 0. So the y-coordinate here is 1. And if we did this right, the y-coordinate should be 1 on the other side too, because the points are symmetrical. Both the points are 1 unit away from the line of symmetry, or the axis of symmetry. All right, now what happens when we go 2 units to the right of the axis of symmetry and 2 units to the left of the axis of symmetry? So if I go 2 units to the right, that would be positive 3. And if I go 2 units to the left, that would be negative 1. So what are our y values? 1, 2, 3, 4. So 3, 4 and negative 1, 4. So if I were to fold that parabola on top of its side, both sides would match up. They're mirror images of each other. All right, let's look at example 1. For each parabola shown below, identify the vertex, draw a dashed line to represent the axis of symmetry, or AOS, and then write the equation of the axis of symmetry. So in problem A, it says, first of all, to identify the vertex. So our vertex in this graph would be negative 2, 1, 2, 3, 4, 5, 6, 7, negative 2, positive 8. So our axis of symmetry would be the vertical line that goes through the vertex. So the equation of that vertical line would be x equals negative 2. All right, now let's look at problem B. Our vertex is right here. Now, I want you to be very careful on this graph because I want you to notice that this graph is not scaled by 1s, but rather 0.5s. So on the x-axis, we're going 0.51, 1.52, 2.53, 3.54. So our vertex here is at 1.5, comma. Now our y-axis is going by 1. So 1, 2, 3. So 1.5, comma 3. Now our axis of symmetry, if I draw a vertical line through it, would be x is equal to 1.5. All right. Now pause the video and try problem C on your own. All right, welcome back. Let's see how you did. So in problem C, my vertex was right here. 2, 3, 4, 5, 6, 7, 8, 9. My vertex in this graph was 0, 9. The axis of symmetry is the vertical line that goes through that point. So hopefully you put x is equal to 0. Now, that's how to find the axis of symmetry if you're given a graph. In our next examples, we're going to talk about how to find the axis of symmetry if you're given an equation. So in the next problem, next definition, we have axis of symmetry formula. When a quadratic function is in standard form, now standard form looks like this: f of x equals ax squared plus bx plus c. We can use the formula below to find the axis of symmetry equation as well as the x value of the vertex. So our formula is x equals opposite of b divided by 2 times a. X is equal to opposite of b divided by 2 times a. So in our example, it says find the axis of symmetry for the quadratic function f of x equals x squared minus 4x plus 2. So the value of a in this problem is 1. The value of b is negative 4. So if we evaluate the formula x equals opposite of b over 2a, I would replace all the variables with parentheses. So I'd have opposite parenthesis divided by 2 parenthesis. Then I'll substitute in our value of b for b and our value of a for a, and then evaluate that formula. So the opposite of negative 4 is positive 4, and 2 times 1 is 2. So our formula for the axis of symmetry here is x equals positive 2. All right, look at example 2. The graph of x squared plus 8x plus 13 is shown at the right. Complete A through D and check your answers with the graph of the function. So in question A, it says fill in the values for A and B. So remember, A is your coefficient of x squared. In this case, it's 1. B is your coefficient of x. So in this problem, it would be positive 8. All right, problem B. Use substitution to write the equation for the axis of symmetry and then sketch the axis of symmetry on the given graph. So our formula for the axis of symmetry is x equals opposite b divided by 2 times a. So I'll replace the variables with parentheses and then plug in my values. So b in this problem was 8 and a was 1. So if I evaluate this, I get negative 8 divided by 2, which is negative 4. So my equation for my axis of symmetry is x equals negative 4. So let's draw a line on this graph at x equals negative 4. So 1, 2, 3, 4, and we'll draw a line right through that point. Now, ask yourself, does that vertical line split this parabola into 2 equal parts, a left side and a right side? And it does. All right. Part C, if opposite b over 2a is the x value of the vertex, use substitution to find the y value. So here's what that is saying. We know, because our axis of symmetry is at the line x equals negative 4, that x equals negative 4 must be the x value of our vertex. So to find the y value of the vertex, all you do is evaluate the function for f of negative 4. Now when I do that, I'm going to write down the function and I'm going to replace all of the x's with parentheses. And then I will plug in the value that I'm evaluating for, which in this case is negative 4. Okay. So that gives me negative 4 squared is negative 4 times negative 4, which is positive 16. 8 times negative 4 is negative 32, and then plus 13. Now, if you want to, use a calculator to evaluate that. 16 minus 32 plus 13, and that gives me, that tells me that f of negative 4 is negative 3. So that is the y value of my vertex. All right. Part D. Use the graph to find the vertex of the function. Does the vertex from the graph match your answer to part C? So go back up to your graph. The vertex of this function is right here. So if I was finding the vertex of the graph, notice I would go 1, 2, 3, 4 to the left, which is -4, and then 1, 2, 3 down, which is -3. So yes, it matches. Okay. Example 3. For each quadratic function below, use opposite of b divided by 2a to find the axis of symmetry equation and the vertex. Confirm your answer using technology. All right, so in this problem, before we use our formula, let's identify the value of a and b. So in problem A, we have f of x equals 2x squared minus 20x plus 51. So our value of a is 2, and our value of b is -20. So I'm going to use the formula x equals opposite of b divided by 2 times a. So I'll replace the variables with parentheses, and I'll plug in the values. So this was -20, and a was +2. Now, you can evaluate that on your calculator if you want to. The way you evaluate this on the calculators, you'd say -20 divided by 2 times 2. And that gives us positive. So x equals 5 is our axis of symmetry. We can write that answer here. Now, to find the vertex, you already know the first number of your vertex is going to be 5 comma something. So to find the y value, you evaluate this function for f of 5. So that means you're going to replace all the x's with parentheses. So 2 parentheses squared minus 20 parentheses plus 51. Now, I'm evaluating this function for 5, so I'll put a 5 here and a 5 here. Now, I would probably use your calculator on these because they can get a little big numbers to evaluate here. So I'm going to put 2 parentheses, 5 parentheses squared, minus 20 parentheses 5, and then plus 51. And that gives us a value of a y value of 1. Let me write this down here also. F of 5 was equal to positive 1. Now, it asks us to confirm the answer on our graphing technology. So we'll say 2x squared minus 20x plus 51. And then I'll push the vertex right here, 5 comma 1. So we've confirmed it graphically and algebraically. All right, next problem. We have f of x is equal to -x squared minus 8x minus 8. So let me kind of separate this problem because I don't want them to get mixed up here. So in this problem, the value of a is -1 and the value of b is -8. You've got to be real careful when you're dealing with negatives here. It's important that you type them into your calculator correctly. So if my formula to find the axis is x equals opposite b divided by 2 times a, I would take the opposite parenthesis over 2 parentheses, and let's plug in our values. So b was -8 and a was -1. All right, let's make a little fraction bar here, and on the top I'm going to put negative parenthesis -8, and on the bottom I'm going to put 2 parenthesis -1, and that gives me x equals -4. So there's your axis of symmetry. I'll write it on this line. And now I know the first number of my vertex is -4. Now, to find your y value, you're going to evaluate the function at f of -4. So negative parenthesis squared minus 8 parenthesis minus 8. And you'll plug in negative 4. Now, again, it's very important that you enter this into the calculator correctly. You need a negative parenthesis, negative 4 parenthesis squared, minus 8 parenthesis negative 4, close parenthesis, minus 8. All right, let's see what we get. So f of negative 4 is positive 8. All right. Now, the question said to check this graphically. So let me erase our other parabola here. So our original function was negative x squared minus 8x minus 8. Zoom out here and click on the vertex. Negative 4, positive 8. Excellent. All right, pause the video and try problem C on your own. All right, welcome back. Let's see how you did. In this problem, the value of A was 4 and the value of B was 0. So when I use my formula, opposite B over 2 times A, we would plug in a 0 on the top and a 4 on the bottom. And that would give us 0 divided by 8, which is 0. So x equals 0 was our axis of symmetry. Excuse me. So I know my vertex is going to be 0, comma something. So when I evaluate this function for f of 0, I get 4 parentheses squared plus 8, and I plug in a 0. So let's do that on my calculator. 4 parentheses 0 parentheses squared plus 8. And that gives me 8. So f of 0 was equal to positive 8. And then we're going to check that on our calculator. 4x squared plus 8. And then press on the, sure enough, our vertex is 0, 8. And that concludes today's lesson, Attributes of Quadratic Functions, Part 2.